And we have some numbers up here. I'm just going to write with this board for a minute. So we have 10 liters of gas. So that, what is that?
Volume.
Volume, good. So volume 1 is 10 liters. Okay. And the pressure is, so pressure 1 is 109 kPa. Okay. And then we have the final volume. So volume 2 is 2.10 liters. So imagine we have a system, the volume gets smaller. So what's going to happen to the pressure? It's going to go up. Good. So we got to make sure that when we figure out our final pressure, that makes sense. Okay, so I always go back to the ideal gas law, which is Pivnert, PV equals nRT. So PV is going to be proportional to the initial pressure times volume is going to be proportional to the final pressure and the final volume. So then we need to solve for P2. So we can do that by just dividing by volume 2 on both sides. So the pressure 2 will be pressure 1 times volume 1 divided by volume 2. Let's do that here. So P2 is going to be 109 kilopascals times volume 1 liters divided by volume 2. Okay, so our liters units are going to cancel out, and the units that we'll get is kilopascals. So just make sure, I didn't copy the box, but make sure that it's asking for the volume in kilopascals. It might switch that up. I think it should be fine. But how many sig figs do we need on this answer? 3. Good, we need 3. So if we look at all of our numbers, they all have 3. So this should also have 3 sig figs. What did you guys get when you did this? 5.2 what? Because we need 3 sig figs.
I can't find kilopascals.
Oh yeah, let's keep it in kilopascals. 109 times 10 divided by 2.1.
Yeah, 519.
Okay. I'm just gonna. That works. And then we also need, if it's 3, we need that decimal there. Okay, questions on that? How did this type of problem go? You guys feel okay? You can do that on the final? Okay, there is going to be one like this on the final, so if this is something that's tricky for you, I would go find it in Alex and practice a few. Okay? All right. Where's the schedule? Here we are. Okay, so don't forget we have a signature assignment. Also, I noticed that a lot of us missed this question on the test. Here it is. And on the last test, so on chapter 11 test, NH2 is amino. So I had on the diagram carbon NH2, so I'll go back and fix that. But moving forward, amino is just the nitrogen and the hydrogens. Okay. Does that make sense? Okay. All right, I didn't realize that was confusing because it made sense to me, but I can see that wasn't very clear. So we are in chapter 12. Lab 5 deadline is Thursday, so make sure you're starting to get your Lab 5 done. All right. We don't have to go on Friday. And then the last lab is next Monday. That's the last time you can get points for a lab. So that's kind of exciting, but also keep in mind, you want to make sure that these last 2 labs are on time so you're not losing points there, and make sure you do them as best as you can to pull up your lab grade if you need to. Let's see. We're also getting pretty close on tests. So we've got chapter 12 test, chapter 13 test, and then the final. So make sure your test scores are where you want them to be too. All right, questions before we start our chapter 12 notes? Okay. think they're over here actually. All right, so this is a little bit tricky. We're going to use IUPAC naming. And what we learned, we're going to build off what we learned last time. So this is just a pattern. You have to learn the pattern, you have to learn the rule, and then once you have that, you're good. Does anyone need the handout we got last time, chapter 12 handout? Okay. This is, I have lots of the rules on here. So we're going to use what we learned last time to name our parent hydrocarbon, and then figure out what the branches are called, and then we have some particular rules we have to follow to name them. And then we should be able to name it, but we should also be able to draw it. If they give us a name, then we should be able to draw the correct structure. Okay, so IUPAC comes up a lot in chemistry. IUPAC is this governing body that decides how things should be standardized. So it's the International Union of Pure and Applied Chemistry. We just call them the IUPAC. And they have decided these rules for naming, so that when I name a molecule, you know exactly what I'm talking about, okay? So this is called systematic naming. There's also common names for molecules. So you might have one name for a molecule, but everyone calls it. So like ethanol, we call ethanol one thing, but that's not the systematic name, that's just the common name. Okay. So using the system, we know exactly what it is. And that's why we're using the system.
What's that word? The IUPAC system of
Nomenclature. This is naming. Yep, good question.
okay.
Nomenclature. That means just naming molecules.
Is this like American specific?
No. International. This is
But like, is it the entire world or is it just like?
So if I name a molecule following their rules, everyone in the world will know what I'm talking about. So if I give them somebody in Europe a name, they'll be able to draw the same thing. Or in China, they will be able to draw the same molecule with these rules.
Is it different with other naming systems like the other ones we learned?
Like ionic covalent?
Yeah, like all that stuff. Is it different internationally?
I don't think so. I don't think so. I think that organic molecules can get really complicated, so that's why we specify that we're using IUPAC. The other the ionic compounds aren't super, right? You only have two.
Mm-hmm.
So they might have some say, but that's pretty standardized. Okay, so these are just some definitions so that you know what we're talking about when we say IUPAC. So here's an example. So this is a drug. So the IUPAC name would be 2(4) methylpropyl propionic acid. So this is like ours probably won't get this complicated. The generic term would be ibuprofen, and the trade name would be Motrin or Advil. So these are companies that have said, I am patenting the way I'm making this molecule, the way I'm crystallizing it, and I'm going to sell it. So they have some rights to that, so they use this name. Ibuprofen is the generic name, and then this is the IUPAC systematic name.
No way.
It's a lot.
It is a lot. So ours aren't going to get that complicated, but if I say this, we could figure out exactly what this molecule looks like based on this IUPAC name. if I tell you ibuprofen, I could look it up, but from my knowledge, I can't just draw that.
I don't know why.
I also can't draw
I was expecting something like letters. I don't know, like CA, like CH. You know what I'm saying? Just like actual compound names.
Is any of it based on like the primes of the carbon? Is that why?
It's based on the positions. Yep, and we'll talk about that.
This is awesome. Okay, next.
So if you take a full semester, right, we're doing 3 chapters of organic. If you take the whole year of organic, you would get some of this. There's a whole bunch of other things you have to learn.
Why are they together?
So these all mean
Belong together.
the same thing. Okay, wait.
So
It's like
does-
a method.
Is it in there's like 2 methylpropyl groups, 4
Same marker?
phenol groups, and
Yeah.
2 propionic
I
acids?
also don't feel this.
We could look it up. Let's see.
Do you feel me? You see where I got
Yeah,
that though?
let's see.
The parentheses, the brackets, and then that one. That's just good.
So this is not something that I'm super familiar with. So we can, let's see. Oh, that's very helpful.
So it is just a propyl group and everything. Methyl group.
I was expecting something like the C13H18O2.
So we have, this is a phenol. We have 2 methyls. This is the propionic acid, and we have another methyl group over here.
Yeah, so then that's probably it right there. So
There you go. Oh, they call it isobutyl phenol because we have a butyl group 1, 2, 3, 4, and it's iso. So this is our isobutyl. This is phenol
Yikes.
propionic acid. That's this one.
So methyl looks like it's the side group.
Okay, so ours are not going to be this hard. This was supposed to be just an example,
Alright.
but we're trying to get to the IUPAC systematic name. So here is what we have to do. We have some prefix. Where are the substituents? And what are they? The parent is the longest chain carbon. That's what we practiced last time. Longest chain carbon. And then the suffix is a functional group. I don't think we're going to get to that today. I think that might be chapter 13. Once we practice this, it'll make more sense. And our step-by-step instructions are on this sheet. So if you don't want to write all this down, they are on this sheet. So we're just building off of what we learned last time.
So what are the functional groups again?
So functional groups are what we talked about in chapter
Last time?
11.
Okay.
So like alcohol group, or we also I think that this part is going to be chapter 13. So if you have a double bond, then that's called an ene. So it would be blah blah blah. So the ene. Or if it has a triple bond, it would be with a y, ine. We'll talk about that.
Good.
Okay, again, this is something that the more you practice it, the more, it's just like some rules, you have to follow the rules, remember the rules. So this is something that I would practice a lot on Alex. And there are a few of these on the final.
Few.
There's at least one. So for our final packet. So number 36 is like this.
Is that the actual text that we're taking?
This is
practice.
like the actual test. There will be different questions. But like on
But the structure will be
33,
similar.
you might get number 33 exact. Like this is a potential test question. So this is for you to go back through and look at Alex and find this question and practice it if you're getting stuck on this one. Yeah. Yep, so 36 and 37 are naming. 38 is also naming. So 3 of them are naming. So this is something that I would make sure and practice. Get really comfortable with that. Okay, so just like last time, we're going to find the longest continuous chain carbon and name it with AIM. This is our functional group for today. So remember, an alkane just has carbons and hydrogens and no double bonds. So that's going to be our functional group. Number of the atoms in the carbon chain to give the first substituent the lowest number, and we practiced that last time. So we want the substituents to have the lowest number. And if we have a tie, then either it doesn't matter or go with the one that lowers the most substituents. And then name the substituents. We have our naming chart. So if it's a CH3 substituent, that's called a methyl. We have ethyl, and we have propyl. And then if it's in the middle of the propyl, that's isopropyl. Okay. And then we're going to use the numbers on the carbon chain to designate the substituent location. So if we have methyl on group 3, it'll be 3-methyl. And these are on, I think most of these are on our chart. Every carbon belongs to either the longest chain or a substituent, but not both. So it has to be part of one of them. But so don't leave it out. But also it can't be a methyl and the first group. Okay. Each substituent, so each group that's not part of the main chain, needs its own number. If I have 2 methyl groups, I need to say 2. And then if I have 2 methyls, I need to say there's dimethyl. Okay. Or if I have 3 methyls along my carbon chain, that's going to be trimethyl. And I need to use numbers to tell you where those methyls are. So it might be like 2, 4, 4 dimethyl something. And this chart is also on our group. So we might have 2 isopropyl, so it would be diisopropyl. Or we might have 2, maybe 3 ethyl, so it would be triethyl, depending on our molecule.
Even if they're bonded in different areas.
Yes. Mm-hmm. Yep. Even if they're bonded in different areas. Yep. Or we could have 4 of something, so that would be tetra. Yep. And that's as far as the Alex table went, so I assume that they won't put more. Okay. This is just systematic naming, so you just kind of rules to follow, so we make sure we all get the same name. You have to alphabetize the substituents, ignoring the prefixes. So if we look at our group, ethyl will come before propyl or methyl. Methyl comes before propyl. Isopropyl comes before propyl. So we care about the alphabetizing the substituents. And then each of these groups, so first we alphabetize them, and then before that name we put a number. So if it's like 1 methyl, and then 2 propyl, and then the parent hexane or something. This is just a reminder, we need a number for each substituent. So if I have 5 substituents, I should have 5 numbers on my molecule name. This is kind of tricky. Alex does care about spelling and also cares about spaces and commas and dashes. So if you have a number and then another number, you're going to put a number, then a comma, then the number. If you have a number and then you have to write a word, you're going to put number, and then a dash, and then the word. Okay. So numbers can't be next to letters. There has to be a dash between them. Numbers can't be next to each other. They have to have a comma between them. And then don't put extra spaces in there. We'll practice some of these. So that's this last one kept making me stuck on Alex because I had the right thing, but I didn't have my commas or dashes correct. Okay, so we're through our rules. Do you guys have any questions before we start doing some examples? Okay. And again, all these, this list of rules is on this handout, and I have extra, and this is also on Canvas. Okay, so here we have this molecule. The first thing that we are going to do, so I'm going to walk you through some examples, and then I'll give you some practice, a practice one. So the first thing that I'm going to do is I'm going to look and find the longest chain and try to name the parent hydrocarbon and also make the substituents that have the smallest numbers. So if I go like this, 1, 2, 3, 4, 5, 6, it looks like the parent alkane is hexane. Okay, but if I number this way, let's maybe change color if we can. Oh, nope. Okay, I'm just gonna use, if I go back the other way, 1, 2, 3, 4, 5, 6. Here I have a methyl group and a methyl group at 2 or 5. Here I have 2 methyl groups at either 3 or 4. So if I number 1, 2, 3, 4, 5, 6, then that puts these methyl groups at the lower number. So I'm going to number this way. Okay. And so then, so hexane is my parent. This is the functional group, ane, because it's an alkane. Then I have my 2 methyl groups at 2. So I'm going to say this is 2, comma 2. Then I have 2, let's see. I actually have 4 methyls. So I'm going to put where these are. This is 1, 2, 3, 4, 4, comma 4. So no spaces. 2, comma 2, comma 4, comma 4. Dash, because now I'm going to put letters. I only have 1 functional group, so I don't have to worry about alphabetizing. This is tetramethyl. And no spaces. So the IUPAC name for this would be 2,2,4,4 tetramethylhexane. Yes?
The tetra comes from, there's 4 of them.
There's 4 of them. Yep, perfect. 1, 2, 3, 4. Good.
Do we not use parentheses?
No, we are not going to use parentheses. Too advanced. Our stuff, we don't need parentheses.
Oh, Alex can never do that.
Sorry?
There's no examples on Alex with
Not that I saw. Maybe next chapter. Not that I saw in this chapter. Let us know if you see that and we can talk about it. Yes? Okay, we got that one. All right, so this is a second example. So I'm going to try to number this a few different ways and see what we've got. 1, 2, 3, 4, 5, 6, 7. Okay, so that would be heptane. Let's check another way. 1, 2, 3, 4, 5, 6, 7. Okay, that would also work. That's actually the same. That doesn't matter because that's the same. We have the same side chains. And let's check this other way. 1, 2, 3, 4, 5, 6, 7. So this one doesn't matter. That kind of looks like. This one doesn't matter because they both start at 4. The substituents start at 4. So our parent hydrocarbon would be heptane. Okay.
7 is heptane.
Yes, heptane is 7. Good. And then I have this side chain with 3 carbons, and I have this side chain with 2 carbons. So what would this be called with 3? Good, we have propyl. And we have, what's this one? Ethyl, good. So now we need to alphabetize these. So ethyl is going to go first because E is before P. And this is at 4, and this is at 4. So this would be 4 ethyl. And then between a letter and a number, we put a dash. 4 propyl. And then heptane. So I left too much space, we'll just put it here. So no space there.
So wait, you don't put all the numbers first? I thought it was like
Because you have to
4, 4, ethyl propyl.
Let's see.
Right? Oh no. Alright.
So because these are not the same group, you have to put one and then put the other one.
Wait, sorry.
So the way we numbered our carbon chain, so this is 1, 2, 3, 4. So ethyl is at 4, and propyl is also at 4.
Oh, where it's attached at?
There, yep, where the 4 is where it is attached. Good.
Okay, but instead, the propyl's at 5. Then how do
Okay.
we do it?
So then all you have to do is change this to 5.
Okay, so in what instance would all the numbers go first?
If it is like this one, where they are
All the same.
all the same group, or if we have 2, we would say like 2 methyl something 5.
Gotcha. Yeah.
That's propyl.
Okay.
Okay. All right, we got one. Okay, try this one. Oh, this looks kind of. Yeah, try it. Try this.
Okay, so at the end, that CH3, CH2, does that count for the carbon chain? Does it start?
You have to figure that out. You have to decide where is the longest one. So this might be something to practice.
It's drawn.
It is drawn differently. I use this chem draw. This is the free chem draw, so this is why it's a little bit.
It's just that.
I couldn't get it to write the hydrogens next to the carbon, so just imagine that the hydrogen is up next to the carbon.
I think I kind of get it. So, this like CH3, would that count as a substitute that like would not have to be a lower number?
It's probably gonna be,
Or would I wanna make it these the lower numbers? Like these CH3s, does that make sense?
so,
Probably these. Well, they're the same thing.
this is probably gonna be the main carbon chain.
This part one?
Yeah.
Yeah, I just didn't know if this would be one or if this would be two.
Oh,
Yeah, it's not.
1,
It's
2,
just
3,
the chains.
1, 2.
Okay.
So probably
So
For sure.
we're only paying attention to
Totally.
these kinds of things?
Yeah.
Because
So this would
one,
be,
two, this would be
oh,
two.
but there's a CH3 and then a CH2. CH3, CH2, so
I
yeah.
literally just asked this, but I just wanna make sure. So the hydrogen's coming off, that like just the hydrogens, we don't need those, right?
They should be next to the carbon.
Oh, I see.
Yeah, they should be like this, but
Okay.
Ken
That
brought
makes more
it.
sense. I was confused.
All right. Are you guys
Hold on.
ready? We need a minute? Okay, that's fine. The 20th should be the Victory Day. Okay.
So is it okay if I take it on the 19th?
Yep.
And then I'll have to work on it after.
Yep, yeah, that's fine. Do you need me to request you on the 9th? Yeah. Yep.
Did they completely dissolve the AP Chem class, or AP Chem class?
Yes.
Is this what took it like?
Yes, I think so. So there's only 5 people that signed up.
Oh,
This year.
Are they
Like,
getting getting done?
so if they could get enough people to sign up for it.
Is it open, like is it a class that's off?
I actually don't know.
Curious. Oh, because there's 6. Are you taking this class again?
So what's the one that's
Yeah.
8.
I have signed up.
If they needed to, couldn't this be teach it as well? Or you
This class?
Yeah.
So they make you have masters or a PhD.
I mean, either way. Because it's okay.
She has a master's degree teaching.
So I just like circling these. And then
That's pretty awesome. Wait,
All right,
masters in
I've
teaching
formulated my
specifically
guess,
chemistry?
right, to see if it's right.
That's so dumb.
Yeah. Right, because you need to be better at teaching.
Yeah.
Yeah, I'm pretty sure the question is.
It's like,
Going
wow,
right
probably has a little more knowledge.
Handful, 2, 6.
Yeah, so there you go. It seems like they're kind
Am I right?
So there's only one ethylene.
I had one.
Two like for only had more.
That's so weird.
Yeah, I agree.
About that.
I'm pretty sure that's
If I
it.
put like this one, if I put 3,
Because
All right, great.
when I 3,
this is just one side.
Let's talk through this one. So I like to start with our parent hydrocarbon. So what is the longest chain hydrocarbon?
8.
Okay, and so what would that be called? Okay, so our parent hydrocarbon is octane. Good. Okay, and then where should we start numbering? Should we start numbering over here or over there? So if we number here, let's try both. 1, 2, 3, 4, 5, 6, 7, 8. Let's try changing the pen color one more time.
Doesn't want to seriously.
It doesn't want to. Okay. Oh, there it goes. Now we can't go back. 1, 2, 3, 4, 5, 6, 7, 8. So which one makes the substituent have a lower number? So this one has a 3. We just care about the first substituent. And then the black one, let's see if we can go back here.
You try touching with your finger. Oh, so JP.
Oh, 2 fingers.
Freaking love this thing.
I don't know. This one is about 2 if we go from this direction. Oh, now it's white.
What?
I wonder how many times you tap it changes the color.
Oh my gosh.
Maybe hold it down.
Huh?
Oh no. Wait, like
Oh.
Slide.
We'll just see with black. So this one is at 2. So we would go with this numbering because this makes this methyl at 2, and this one makes it this methyl at 3.
So we only look at the first one.
Yep, and then if it's a tie, we look at the other ones.
Okay, because I was thinking like the majority of these are going to be at a lower number, so that's why
Yeah.
I was the right one.
I agree with you, but we care about the first one. Good, good. So this is, what is this group called? Methyl. How about this one? Okay, ethyl at what group? This is 5, right? Ethyl at 5. And we have another methyl. Okay, now we alphabetize. So which one goes first? Ethyl. So we're going to say this is at 5. So 5 dash. So we put a dash between number and letter. 5 ethyl. And then we put another dash because we're going to come up with
2 and 6, right?
good. So 2, 6. So 2, then comma, then 6. And then what would we call this? This is dimethyl.
Oh, rats. Wait, is there a dash between the 6 and the diamond?
Oh, yes. Thank you. Good. So number, letter, dash. Good. And then octane. No space between that and octane. Yes.
so like in the main chain, why isn't there a bond between 3 and 4?
Because ChemDraw wants to draw like that.
Oh, it's just the drawing.
Yeah.
Okay.
And I didn't want to do Photoshop. Yeah.
What's the 2 after ethyl?
So this says we have a methyl at 2, and we have a methyl at 6. So this is 2, 6 dimethyl. We have 1 at 2, 1 at 6.
Low key, the parentheses, the business might be easier.
I think, I'm not sure where that one happens.
So
That was
I don't know why, but I've convinced myself I already know how to do that.
So 6 is separate from the ethyl. Why is there a dash? Because it's been.
So the dash goes between, so this is one molecule.
Yeah.
Okay, so we have ethyl at 5, and then we have to keep saying the same molecule. So between a letter and a number, we put a dash. And then we have 2, 6. So on octane, we have 2, 6 methyls. Methyls at 3 and 6. Numbers go with something in front of them.
Yeah, I think of it as like if it's different, do a dash because it's like a
Okay, yeah, if they're different, do a dash. That's a good way to think of it. Yeah, good. Okay,
Slide.
questions. This is kind of tricky, but once you get the pattern, it's not too tricky. So practice with these rules. This might be something to put on your note card if you can't remember them for this test. I think that's all I have for these sides. Okay, so we have plenty of time. We have like half an hour. So I would probably go through and practice some of these in Alex. If you're getting stuck, ask your neighbor or ask me. We can help you get through some of these. If you haven't done Lab 5, that's also a good thing to do. Turn that in, I'll grade it. Or if you haven't done the pre-lab for the next lab, that would be another good thing to do. The last thing we're going to talk about is cycloalkanes. So if you get to those, that's what we're going to talk about next time. But I have the slides up, or you could probably figure it out with the Alex instructions.
Yeah,
I like them.
Alex instructions, like, made my existence, I hate those things.
And they do stuff you don't even really need.
Yeah, and then I always